or linear equations where the solution is the point where the two lines intersect. So here's the point where you pause the video and write this down. Now, if I'm solving a system, there's two main methods I can use. This video is going to talk about how to solve a system using substitution. So solving by substitution means I'm going to take one of these equations and solve it for a variable, and then substitute what I find into my other equation. So let's learn by doing here. So my goal here is in one of these two equations, I want to isolate a variable. I have two equations here. Now I look at this equation and I see the easiest variable to isolate is probably going to be the y in this equation, because it's just by itself. It doesn't have a coefficient, or rather it has a coefficient of 1. So I'm going to take my second equation here. I have 4x plus y equals 24. If I subtract 4x from both sides, then I have y equals 24 minus 4x. So this one way of saying this is I have found y in terms of x. I have y here by itself, and on the other side I have an expression which only has x as a variable. So that's y in terms of x. So now that I have found what y is in this equation, I'm going to plug y in to y in the other equation. So instead of that other equation, I have 2x minus 3y equals negative 2. Now I'm going to have 2x minus 3, but instead of y, I now have this whole quantity as y. So times 3 times 24 minus 4x, 2x minus 3, and then that equals negative 2. So this is 3y equals negative 2. Now what this has done for me is I no longer have y in the equation. I only have x. And we know how to solve an equation that only has x in it. I'm going to distribute the 3. We have 2x minus 3 times 24 gives us negative 72. And then negative 3 times negative 4x gives us plus 12x, and this equals negative 2, 12x. Then we just combine like terms on the right side, so we have 14x minus 72 equals negative 2. And we're going to add 72 to both sides. So then 14x equals 70. Divide both sides by 14. We'll get x equals 5. Now at this point, we know what x is, so we just take what we know about x and plug it in for y. So I know x is 5. I can plug it into either equation. I'm going to use the bottom one because it just has a 1y, but it doesn't matter. You can use the top one. So we have 4 times 5 plus y equals 24. So 20 plus y equals 24. And then minus 20, minus 20, and y equals 4. So then the solution to this is a point where they intersect. So I know x is 5, y is 4. So the solution to this is the point 5, 4. Because 5 is x and 4 was y. All right, let's keep going. Let's do another one. In this example, we have 7x, negative 7x, minus 2y equals negative 13, and x minus 2y equals 11. Usually systems of equations are written with these, like a single set bracket. I don't know who makes these things up. So if I'm solving by substitution, again, my goal is to figure out which variable is easiest to isolate here. And in this one, again, I have an x that's by itself, so I'm going to go ahead and isolate x. So I'm going to find x in terms of y in that second equation. So if x minus 2y equals 11, then I add 2y to both sides, then we would have x equals 2y plus 11. Now it's important that I substitute this into the equation I haven't used yet. If I were to go and substitute this back into the equation I started with, I would end up with something that doesn't help me. It's true, but if you don't use the other equation, then you go in a circle. If you want, you can try it out. Pause it right now, try it out, see what happens, and you'll realize you did nothing for yourself. So, we'll plug this into the other equation. So we have, now instead of x, we're going to have negative 7 times, and we found that x is 2y plus 11 minus 2y equals negative 13. Again, I'm just going to solve this like I would any equation. So distribute the negative 7. We have negative 14y minus 77 minus 2y equals negative 13. Negative 14 minus 2y gives me negative 16y minus 77 equals negative 13. If I add 77 to both sides, then I have negative 16y equals, I want to say that's 64. Should be 64. It's 64. And then I divide both sides by negative 16. And I'll get that y equals negative 4. So now I know what y is, but I'm not quite done. I've got to plug that in and find what x is. And as I said earlier, it doesn't matter which equation I plugged into at this point, because at this point I know what y is. I know it's negative 4. So again, I'm going to pick my second equation. It has smaller numbers in it. So plugging negative 4 into the second equation, we have x minus 2 times negative 4 equals 11. Negative 2 times negative 4 is going to give me x plus 8 equals 11. Then I subtract 8, and x equals 3. So then the solution to this system of equations is 3, comma, negative 4. This is the point where those two lines intersect. So we can do one more on substitution. Let's make this one a messy example. That way you can see the downfall of substitution sometimes. So how about negative 3x minus 4y equals 2, and 3x plus 3y equals negative 3. So in this one, all of the equations have a coefficient, or all of the variables have a coefficient. So you can see here it's a little bit harder to solve for one of the variables. I'm going to pick one of the ones in the second equation, although it doesn't matter which one you pick. The substitution method still works. For me, it looks like either x or y in the second one is easiest to solve for. So I'll solve for x in the second one. So 3x plus 3y equals negative 3. I'll subtract 3y. Now I have 3x equals negative 3y minus 3. And now I have 3x. I need to divide everything by 3 in order to finish solving for x. So if I divide everything by 3, then x equals negative y minus 3. So now I've got x in terms of y. So I'm going to take what I know from here, I'm going to plug in negative y minus 3 into the top equation. Remember, you've always got to use a different equation when you use substitution to plug that second one into. So we have negative, I should write this somewhere else maybe. So x is negative y minus 3, so negative 3 times negative y minus 3 minus 4y equals 2. So we'll distribute the negative 3. Negative 3 times negative y gives me positive 3y. It's a negative times a negative, and negative 3 times negative 3 gives me positive 9 minus 4y equals 2. 3y minus 4y gives me negative y. So then negative 1y really, plus 9 equals 2. If I subtract 9 from both sides, then negative y equals negative 7. Remember, you don't solve anything for negative y, so there's ways to look at this. I like just saying I'm dividing by negative 1, because that's going to change the sign for me and get me positive y equals positive 7. Now that we've found what y is, again, we just take what y is and we plug it in for x. Or plug it in for y and solve for x. So, y is 7, then doesn't matter which equation. I'm going to pick the one that has positive numbers. So 3x plus 3 times 7 equals negative 3. So that's 3x plus 21 equals negative 3. I subtract 21. 3x equals negative 24. Divide by 3. And we'll have x equals negative 8. So we've got y is 7 and x is negative 8, which makes our solution negative 8, comma 7. All right? These two lines intersect at the single point, negative 8, comma 7. So that's going to conclude my video on substitution. These substitution problems can sometimes get really messy. I know they take a while, but if you understand what you're doing and you're careful, then they're not so bad. Because conceptually, substitution is not too bad to understand. All right?